Hi everyone. My name is Anibal from the Dominican Republic. I am an electronic engineer that started programming embedded systems, turned it into a full-stack developer, and now I'm diving headfirst into the world of agentic AI. As you can see from my pad, I like to learn new things and find creative ways to combine them. And who knows, maybe by the time I'm retired, I will have a team of agents running my shop. In this presentation, we will see my main motivation to participate in this hackathon. Also, the dataset, methodology, and application functionality are well true to the Jupyter Notebook components, and a real-time demo and screen recording of the different tools that the agent used and how the algorithms work in the Jupyter Notebook, trying different queries to see the application in real time. While ArangoDB provides excellent sample datasets, we opt for a custom dataset for the specific use case, leveraging the data of places and amenities in OpenStreetMap or any map service like Google Maps to unlock valuable insights into local market dynamics to identify opportunities and service gaps. We named the project Geo X-ray because we can view a radiography of the map data. We start with the raw data in Google Maps, then transform it into a graph structure where each location is a node and connections are edges. Now let's dive into our agentic application in the Jupyter Notebook. Then we have to install in the step 1 the required models, then import these required models, load environmental variables, then we have to connect the database to the client database, and the step 4 is where we prepare the dataset for the NetworkX and ArangoGraph database. In step 4, we prepare the dataset for not only NetworkX but to make it available for any graph database. We extract an example of the graph data from a specific location in the map like Puerta del Sol, Madrid, Spain, and we take a point of interest in a 500-meter diameter. As we can see here, we take all the nodes and put it in a graph and plot it where we can see here all the restaurants in this zone. Now that we have visualized the data, we can put the data into ArangoDB database. We take sort of the same script before and then we put this in nodes and edges in the database. And as we can see, all the places are loaded and read it in the ArangoDB database. If we didn't want to generate the data for a specific location, we can skip step 3 and 4 and go directly to step 5 to retrieve the data that is loaded in ArangoDB graph. Here we can see the script and we retrieve all the data that is in this database, and we can see here the nodes and the edges that are available in the database. Now the fun part. We have here the Agentic App, where is the core of the application. We have here the AQL tool that was provided in the template. We have made some improvements not only in the code but also in the prompt for better results. Here we have a NetworkX wrapper just like in case of AQL. We made a custom wrapper just like the same structure where we have here the different functions and properties. Also here we define the tool for event queries. We have a sequence diagram on how the event queries can separate between AQL, NetworkX, and then in the end combine it for giving a response to the user. Here we have all the functions. There are some creative ways of separating and ensuring that the separation or the retries by different combinations of queries. Also, we have the query function. It's called QueryGraph. We have these functions or tools to convert AQL to AQL to text. Also the same for NetworkX and hybrid queries. One fundamental part of the application is the classification agent that classifies or routes which agent will be called, like it will be AQL only, NetworkX only, or the combination of the two. We have here the prompt and all the different functions. We have also defined a multi-agent in LongChain, and here we can test the query or different queries that we have here. We have putted a little tag like this query is best suited for NetworkX or for AQL, and also verify the start time and end time and see the different results. We have a test area that is just only for tests to see directly in the database if the results are congruent with the data in the database. And finally, we have the UI interface using radio to see this in an application friendly where you can put the query here, see the output or pick between a list of common questions for the database and see the result here. As we face some challenges, we also have creative solutions to overcome them, like using or refining prompt engineering using Searshot, chain of thought, and examples. Error handling for making multiple retries and using different interpretations to solve queries. The validation of the AQL and NetworkX queries generated before the execution from the LM. Also, we make a custom rack for taking into account the whole documentation of AQL and NetworkX to improve classification and reducing retries based on syntax errors and a lot of stuff. Now we're going to make some queries. First, we will do it without the UI. For example, I have these queries, which each query have what method is very suitable, like here is AQL, here is network X, and so on. A hybrid, all kinds of questions. For example, if I want to ask in natural language, find the 3 closest restaurants. When I run, this will run this carry graph function. I have the query here as a parameter, and false means it won't use th. Use the rack documentation from network X or AQL. Here I print the result. If I hit run, it classify the carry. The classificator says it's suitable for AQL. Then it makes the AQL query, get the results, and convert it back into natural language, meaning that Pepe Taco, Dixie, and Jiggle King are the closest restaurants based on my request. If instead I query, find the restaurants with the most connections in the database. I will run the query, it should classify it at network X, then execute the query, and the restaurant with most connections is this restaurant. Another interesting question will be how many places there are for each type of amenity. If we run, we can see the different type of places and how many there are in the database. So with this information, we can see if there is competition or not, or there is a need for any service, or if we want to be more specific, we can query what is the amenity type with the fewest instance in the area. Here we can view the broader change as the fewer instance. For a hybrid query, we put, for example, find the nearest restaurant with a 100-meter radius of the cafe with the most connections. That is an hybrid query, and then this execution classifies the query as hybrid. Later in the process, the algorithm makes 3 natural language interpretations to see if one interpretation fails. Then it takes another and another to see if the interpretation of the query in natural language is what it really means. So the algorithm splits in 2 parts, the AQL query and the network X query. Here is the whole process, retrying and testing all kind of things, and later when it's finished, it says the final result based on the request. I've identified the cafe with most connections in the database. The cafe with the highest number of links is Burger King. So I have also found several restaurants located at this distance from the cafe. That includes all these locations. So this is the part that shows you can make a lot of queries of different classification, hybrid, network X, or AQL, and see the results. Finally, I want to say thank you to the organizers of this competition. We have a lot of fun, learned a lot, and maybe avoided some bugs. We appreciate the chance to be able to share the work with you and learn some new cool things in the process.